So that's what that is, but we'll talk about that in a bit. For now, we need to do homework. So there were 2 homework pages. Okay. He didn't ask for it. He was just asking, the question was, are we going to have 2 quizzes like we did in statistics? Because in statistics, we had 2 quizzes. Here they are, see? And I only had 1 for you, and I felt bad, so I made 1 up. So I have a second one.
Great, thanks.
No, it's good for you. It's like practice. We don't collect it. It's the day before the exam. First page, we had 2 pages. First page, these are directional derivatives and gradients. Was there any trouble with that, or was that super easy? That was super easy. What do you think, Andrew? Wait, number 12? I don't know. Let me look. Number 12, find directional derivative. Is this the right one? Yeah? Yeah? Okay, so directional derivative. So first things first, we have to get f sub x. F sub x, quotient rule, yuck. Low D high minus high D low over low low. Look at this, even I, at my late age, has to remember low D high minus high D low over low low. Okay, we're going to do f sub y. So we're doing 12, right? 12? I'm doing the right one, Em. Okay, fortunately for number 12, f sub y, we don't have to do that whole low D high business. I'll just do x times x squared plus y squared to the negative 2 times negative 2y. Okay, so chain rule. I used the chain rule there. So if you write this as x times this to the negative first power, multiply by negative 1, change that to negative 2, multiply by the derivative of what's inside, derivative with respect to y. So that's what I got. Okay, now we can use this point. So f sub x at that point is going to be, give me a sec here, 5 minus 2 is 3. You'll have to let me know if I get any of this wrong. 3/25, I believe. And then f sub y at 1, 2 is going to be, what's that going to be, negative 4 over 25, I believe. So you can double check that I've gotten my, done my arithmetic correctly. So I plugged x equals 1, y equals 2. Everything look okay? No one's complaining. As we found out, was it yesterday? I forget. There was a day where it was just, I was failing left and right. So hopefully today will be a better day. Okay, now I need to do the directional derivative, but you'll notice that v is not a unit vector, so I need to write that as a unit vector. So the unit vector that points in the same direction as v is this, 3 over the magnitude of v and 5 over the magnitude of v. The magnitude of v is the square root of 34. How do I know that? Because I can square 3 and I can square 5, both in my head, and add them together. 3 squared 9, 5 squared 25, add them together, you get 34. Okay, we're almost done. Now we just have to do the directional derivative. Directional derivative of f in the direction of u, which is v, same direction, is going to be 3 over radical 34 times 3 over 25. I guess it's minus 5 over radical 34 times 4 over 25. Ooh, this is fun. 9, 20, that's negative 11 over 25 radical 34. How's that? How's that? Did I get it right?
Probably I definitely get it wrong.
Okay, but now we got it right. So wherever it was that fell apart, probably the most likely culprit, if you didn't do it correctly, is not realizing that you need to make this into a unit vector. Another problem is the derivative, because quotient rule, especially when you're doing partial derivatives, seems to be all sorts of difficulty. So you could avoid quotient rule by using the product rule if you really want to. I remember doing that all the time, however long ago it was. 40 years ago? Almost 40 years ago, 38 years ago probably was when I was taking this class. Okay, anything else on that problem? This problem look okay now, 12? Okay, what else from this page? Does this look good? Look at that, pictures. No one's complaining. All right, so you'll do fine on the quiz and on the test. This is all easy stuff. Gradient, gradient. Okay, let's do the second page, and then we'll pull out the quiz. Here's the second page. These are all finding critical points. And, oh, look, they even give you pictures. I love the pictures. So did you have any trouble with any of these doing the algebra? Derivatives. There is that quiz 20b that I ended up making, even despite the fact that Cooper did not want it. So I'll set the record straight for you, Cooper, all right? He says he doesn't want it, but I made it up. So we'll have some practice with this, not to worry. By the way, quiz 20b is just this surface right here, so very exciting that we get to find out where those maxes and mins are. All right, no questions on this? This wasn't bad? Hey, I'm happy. Okay, let's take a quiz. So here's quiz 20A, or it's just quiz 20. As always, since it's the day before the exam, I won't take this. I do have, just so you know, in here there is all of your old quizzes, and that's a great place to look for good practice problems, especially if you've made mistakes on the quizzes. So do dig through. You can leave your homework in here if you don't want it. But do dig through and grab your quizzes to see what you did wrong so you can fix that for future. Here we go. You can pass the extras over there. I'll come over there, don't worry. So here you go. Pass the extras all the way across to Daniel. Here's a few. This one. I'll give you these two. I think there's two there. There's two. Is there two? You think there's two, but it's hard to tell. Seriously. Come over here and get these two people in this. You didn't get one, did you? There's two. And you guys didn't get one, just Daniel? Nice. I love Daniel more than I love the rest of you. Yeah. That's it. Homework. I'll pile up your extra here. All right, did everyone get one? Whoops, did I just mess? This is your muscle drink here. You're gonna get those the 6-pack. I know that's your goal for your life goal. Like I said, you get it and then it goes away pretty quickly if you don't maintain it. I can tell you that from experience. Yes. Priorities change with time, though. Okay, so when you get done with that one, where did my quiz? Oh, there it is. There's quiz 20b. So when you get done with the first one, quiz 20b is just this surface, this purple surface. So that's fun. And basically just find the critical points and classify them. Excuse me. Okay. Madagascar. Mm-hmm. By the way, if you're looking for somewhere to do number 20B here, you can just flip this over. Do it on the back. All right, I'll give you about 30 more seconds, and then we're going to go over 2 quizzes. First one hopefully didn't take you too long. I don't know how long the second one's going to take because I haven't done it yet. I'm still looking at it. But I think I know what the answers are because I have this beautiful plastic chunky thing. All right, I think we're ready, at least most of us probably, at least to see what the answers are. Hopefully I got them right, but if I didn't, you can correct me, and I will just go and crawl up into a fetal position in my office and wait for the rest of the day to expire. But let's go ahead and take a look. So first one, we're just doing the derivative with respect to x. Did I get it wrong? I think I got it right. Yeah, so that's easy enough. And then the second derivative with respect to x wasn't too bad because you're just doing the derivative of that with respect to x. Those are all constants times x, so just get rid of the x's. So far, so good? Okay, good. I'm happy. Next is the gradient. The gradient was just the derivatives. Derivative with respect to x, derivative with respect to y. Since I didn't specify a point, I'm just going to leave the letters in there. So that's it. And then finally, the directional derivative. This was a little annoying because I didn't specify a point. So we don't know where it is that we're interested in the directional derivative. We just have a vector. And so, but the vector at least was a unit vector. And so I just took the first derivative. I probably should have put the radical 11/6 in front. But it's this, since this is a unit vector, take that times f sub x, and then add to that this thing times f sub y. And that's the directional derivative. So technically, it'd be nice if we knew where it was that I was standing, so I could know what the slope was in whatever direction. Well, that direction is roughly like that. So if I'm standing here, is this uphill, downhill, straight across, that sort of thing. But you could, if you had a point, you could do that. Okay, so that wasn't too bad. The next one, I put this on here mainly because even though everyone bombed it, well, just about on the very first time I did this, the second time only about half of you bombed it. So I'm hoping that this time only a quarter, maybe this is like a exponential decay, where only a quarter of you will bomb it. That way on the test, only an eighth of you will bomb it. But anyway, so the first thing to do, of course, is to explore like what's going on. Take that function and set it equal to some constants. I just picked 0 and 1, and to be honest, those are the only 2 that I did. But you could do more than that. So you take that equal to 0, you get x equals y squared. Take that thing equal to 1, you get x equals y squared minus 1. I started seeing what the pattern was, and I called it a day. Oh, I didn't label, so I lose a point because I didn't label. So here's my, I did it in rainbow colors. but this would be -1 here. This is 0. This is 1, 2, 3, and 4. But there's a bunch of parabolae. I didn't even label the, well, here, 1, 2, 3, 4, 5. This is 5 there. 1, 2, 3, 4, 5. So this is, oh, this is 4, -4. 1, 2, 3. This is +4. Wait, I can't count apparently. That's actually 4, isn't it? There, that's 4, -4. That better? So I've labeled everything as best I could. But you get these nice parabolae. So there's that. And then now let's go on to the fun one, which was the special request. So I've got this here. We can get a view of it. Just a minute, just for because there's 2 people who aren't here. They're going to want to see what I'm holding up. So give me a sec. Let me find my camera. Camera? There it is. Okay, there it is. So it's this thing. So you can see here. And so we'll check. I don't know what the orientation is because I didn't label this. At least I labeled the back with the functioning. But you can see here that there are definitely 4 critical points, 1, 2, 3, 4, minimum, maximum, and those 2 are saddles. So let's go ahead and see how this works in the actual math, and then we'll go back and check the model to see if we're right. So f sub x, we've got, what do we got? 6 6xy minus 6x. Is that it? Oh, how nice. Okay, so I'm going to put a line here because oftentimes it helps to sort of separate f sub x from f sub y, and then we'll deal with combining them in the end. So f sub y is 3x squared plus 3y squared minus 6y. Do I have that? Okay, so I want these to be 0, 0, 0. Now for the hard part. And this really is, I mean, the calculus is not hard, is it? It's the algebra. The algebra is a killer. And so I tell students in Calc 1 that if you flunk Calc 1, it's not because you don't know calc. It's because you don't know algebra. Algebra is the Achilles heel of calculus. Because look at this. What do we do with this? I have to solve 2 equations, 2 unknowns. Let's do it. So the first thing that I would notice is that you can factor the one on the left. So let's do that. And you get these 2 answers, x equals 0 or y equals 1. And I got to say that this is so important that these are two separate answers for this equation. It might be that neither of those work with this equation. So don't just assume that you're going to combine those. You need to have something from the left and something from the right. Okay, now that we've got that, let's plug those. This right equation is way more complicated. 3x squared, 3y squared, minus 6y equals 0. So what I'm going to do is I'm going to take these and I will plug them in over here and see what happens. When x equals 0, I end up with this equation. I can factor that. That's easy enough. And that gives me y equals 0 or y equals 2. I'm going to draw a little wavy line because we're going to switch gears. Okay, I'll put it all together in just a minute. Don't worry. So, but what this means is that if x equals 0 makes this side 0. So f sub x will be 0 when x equals 0. And then if you take that x equals 0 and plug it into f sub y, you find that y has to either equal 0 or 2 for this to be 0. Now let's change gears and say, well, what happens when y equals 1? I'm going to change gears, change colors. So when y equals 1, you have y equals 1, and plug that into this. 3x squared plus 3 minus 6 is equal to 0. So I've just plugged y equals 1 into the green equation. And that's going to give me 2, let's see, what is this? 3x squared minus 3. So x equals plus or minus 1. Do I need to write it out? No, I think we can all figure it out. X equals plus or minus 1. So yeah, just divide everything by 3 and you get x squared minus 1 equals 0. Okay, so this is the crucial point, is understanding how you sort these out. Since I've color-coded these, I don't want to mix colors. That's the deal. Is we're gonna segregate by color here. Red goes with red, blue goes with blue, and you never put blue with red. So this won't go with that. Because the point is we want to make sure both f sub x and f sub y are 0. And the only way for that to be is if you take the thing you have over here and match it up with the correct things over here, and so on. So I'm going to make my list. So here's my list, and then we'll figure out what's what. So we have x, y. Sorry, I'm going to zoom out quite a bit. I have x equals 0, y equals 0, x equals 0, y equals 2, x equals 1, y equals 1, x equals 1, y equals, oh, no. Look at that, even I got missed. It's easy to get lost in all of these numbers. There are the 4. So here, I'll zoom just to where you can see everything that's important. There it is. So hopefully you can see everything, and those are the only 4. So here's what I want to know from you. I need to know, first of all, if you don't understand where one or more of these came from, let me know. I'll try to explain it again. Second thing I need to know is if you think that there's another point that belongs on this list. I need to know that. Because I could have made a mistake. I don't think I did. But we can check. In fact, I hope you have one that you think should be on the list. Does anyone have one that you think you have one?
Is it 1, 2?
1, 2. Oh, I love that. Let's put 1, 2 on the list and see if it belongs there. So 1, 2. Here's how you can check to see if 1, 2 is on the list. Let's go back up here. And you see 1, 2 should make these two, give me a sec, should make these two equations, I'm just copying, they should be true. Thank you. Thank you, Nolan, for coming up with an additional one here. Okay, so if 1, 2 is on the list, what it means is that it should make both of those equations true. So we can check. We can check to see if 1, 2 belongs on the list. Let's do it. Let's plug 1, 2 into the first equation. You get 6 times 1 times 2 minus 6 times 1. Does that equal 0? We're going to find out. We can also do the same thing with the equation on the right. 3 times 1 squared plus 3 times 2 squared minus 6 times 2. Does that equal 0? Let's find out. Okay, so let's see. I've got 3 plus 12 minus 12. Wait a minute. That does not equal 0. Oh, and same thing over here. This is 6. 6 is not the same as 0. So no, 1, 2 does not belong on the list. But if you ever want to check, that's why if this is, like if you're worried that you either have something on your list that doesn't belong there or that you've got something else, you can always take these. If you do this with any one of these, you'll find that both of these equations are true. So is there any other pair of numbers you want me to check? Because we want to have the slopes both be zeros. Slope both be zeros. Let me pick one just to show you one other example. So yeah, Nolan, I appreciate you coming up with this one. I'm going to come up with another one. Let's do this. Here, look, x equals 1 and y equals, oh, we already did 1, 2, didn't we? How about this? Y equals 1, x equals 0. That feels good to me, doesn't it? Feels good to me. So let's try it. Y equals 1, x equals 0. I think you can guess where this is going to go, but let's make sure. If I plug 0 and 1 into these, I need to change this. Just a minute. And I need to change this. I think that's all I need to change. Okay, so I changed this to 0. And I changed that to 0. Let me get rid of all of this mess. So let's see, do these work out? Oh, look, it works out on the left. hey, this is working out. Oh, on the right, it doesn't work out. So not, wait, does it? Hold on a minute.
Yeah, it's.
Oh, the two. It's supposed to be 1, not 2. Sorry. Okay, phew. I was getting worried that, wait a minute, how could this work? It's not supposed to. Okay, thank you. That's right. I changed the X and the Y's. That should be a 1. Ah, there. Okay, so the one on the left still works. Hey, we're excited. And then we get to the one on the right. Womp, womp. No, doesn't work. Sorry. So that one doesn't work. We're sad. So that one, we cross off the list. So that's one way you can check to make sure that you have the correct points. Okay, now that we've got them, if you believe me, any other questions? Do you have a point that you think belongs on the list, or do you think one of these doesn't belong there? I can do the same thing down here with those 4. Okay, once you're satisfied with your points, let's plug them in to the following. We're going to do f sub xx. I'll write it down in a minute. F sub yy. You do all of the second derivatives. And f sub xy. There's the 3 different derivatives. And then we're going to do d, which equals f sub xx times f sub yy minus the mixed second derivative squared. So there's what I know. It's a lot to take in, but let's get this done. Just a minute. I need to write down my second derivatives. It looks like the second derivative in the x direction is 6y minus 6. Second derivative in the y direction is 6y, also 6y minus 6. Interesting. And then the mixed second derivative is just 6x. Here, double check my derivatives. So I'm doing the second derivative of this one with respect to x, the derivative of this one with respect to y, and then the derivative of this one with respect to y. That's the way I did those. Does that look all right? Okay, let's pound through this. Now that we got that down, we can do this really quickly. I'm going to plug in my points, x and y, and get a number. This will be -6. This one will also be -6. This one will be 0. When I do this, I get -6 times -6 minus 0, which is equal to positive 36. Positive 36. We'll classify this in a minute. Here we go. I'll do this quicker. This is going to be, let's see, positive, sorry. Okay, so 0 and 2, that will be positive 6. This will be positive 6. This will be positive 36. No, what am I doing? Positive 12. No, positive 0. Sorry. I don't know what I'm doing now. I see, it's so easy to get lost in the numbers. There's so many numbers here. Yeah, you guys are better than me at this, apparently. Okay, so I'm doing well now. 6 times 6 minus 0 squared is also 36, positive 36. We'll classify these in a minute. Okay, let's see if I can do better with this one. This is 0. This is 0. This is 6. This will be 0 times 0 minus 6 squared, which is negative 36. This is 0. Oh, no, it isn't. 6 times y minus, oh yeah, it is 0. That's 0. This is 0. This is negative 6. So 0 times 0 minus negative 6 squared, which is also negative 36. Okay, so let's interpret this. All we really care about is that this is positive, positive, negative, negative. We don't really care that it's negative 36. It's just positive or negative. The negative ones are easy. Those are saddles. Saddle. This one's a saddle. The ones that are positive, you have to go back and you have to investigate one of these. So when it's positive, the discriminant or determinant, when it's positive, you go back, you say, what was my second derivative? Second derivative positive means concave up, you're at a minimum. So that would be a minimum. And then the same thing for the top one, positive, this determinant, then those are both negative. That's concave down. So you think of a maximum when you think concave down. So that's a max. So let's see, where's the summary? My 0, 0 is a maximum, and 0, 2 is a minimum. And then the other two are saddles. Here we go. I've got it oriented properly now. So let's go ahead and show you the thing. Maybe there it is. Okay, so there it is. Isn't that beautiful? So here's 0, 0 is a maximum. Here's 0, 2. You can see that that's a minimum. And then here are my two. So this is 1, 1, and this is negative 1, 1. And those are both saddles. And you can see there that you have you've got this, you can see it's like a ridge, like a pass, a mountain pass. That's a good way of putting it. So there's my my stuff. Isn't that fun? Oh, I love it. Okay, ooh, I've got a text. I don't care. All right. Wow, any other questions about this? Wasn't that fun? Okay, now I know what you're really most anxious about is what's going on Friday. So let's take a peek at this. Someone emailed me and complained that I hadn't uploaded the stuff that I should have last night, and then Moodle stopped working, and so I couldn't do it last night, but I did it this morning. Or did I do it last night? I forget. So here's what I have. I just dug this out of my files, I should say. So we need to take this with a small grain of salt, not too big of a grain of salt. So these are sample problems. So the main thing to note is that your exam will not be 9 pages long. So this is 9 pages long. Yours will not. In fact, I'll show you yours momentarily. So yours will be 4 pages. And you won't have quite as much of this stuff. So you probably could skip some of this stuff and just go to the end. In fact, what I would do is I would just go to the bottom, start down here, and work your way backwards. You know, the matching, that's all fun, isn't it? So match all that stuff, see if you can do it, and then work your way backwards through this. So we have the matching, we have some tangent plane action, we have some gradient stuff, what is this stuff? Yeah, so there's some stuff that isn't, is there a gradient on here or directional derivative? I don't see a gradient or directional derivative there. Maybe it's further up. I just copied a bunch. Oh, aren't those cool? Those are so much fun. Oh, well, anyway, some more matching. Yeah, I didn't see any. You will have, I know that there's a directional, wow, this is a duplicate. There are directional derivatives and gradients on the exam. More tangent planes. Man, I must have just loaded everything up. Tangent plane. Still no gradients. I had many opportunities to put a gradient or a directional derivative. There is at least one on your actual exam, just so you know. So not only should you study this, you should study your quizzes. So bear in mind that your actual test is only 4 pages long. Let me find your actual test here, and then we'll see what sort of questions you have. That is the exam for statistics. Let me pull this back over. Let me find your exam. Give me a sec. Let's see, open recent, statistics, exam. I don't know which one it is. Is it this one? No, that's statistics. Just a minute. I'll have to start from scratch. I'll find it here, don't worry. Almost there. Test 2, multi. I got it. Okay, let me just doctor it up here so you can see the whole thing. That's what I wanted to do. Let's see, can I see it? Oh, I can see it all. Okay, I can see it all now. Okay, here we go. So now you can see it all. Where is it? There it is. Okay, yeah, so here it is. So you can see that there are some matching here. You can even almost see, if you watch the video, you probably could zoom right in and see what those surfaces look like. But I have them in full color, and I printed it in full color because I care. But anyway, there's down here, that's just this. It's this, the thing that you had on your quiz today, the contours. I thought, just stick that there. So there's a matching, there's some I don't know, this is like derivatives, partial derivatives. There is a directional derivative in here somewhere. There's another matching you can see. I don't know what that is. I don't know what this is. But for sure, I do know that, you know, if you look at the first few pages of the practice test, it's all stuff from the first exam. All of that stuff got crammed onto this first page. So I didn't have as much stuff. I'm not making you do any graphs, obviously. But there is at least one, like, what's the slope of a parametrically defined curve? I don't know what this stuff is. I think there's polar and rectangular coordinates. I don't know what this is either. I think that's vector stuff, some vector stuff. Like, can you do a cross product? It's all pretty easy stuff. I think you'll be fine. Oh, I know, a plane, like if you have a point and a vector, can you do the line that goes through that point? That sort of thing. I think there's examples on the practice test. So you might have not had a chance to look at the practice test because I just uploaded it this morning because Moodle was being dumb last night. But is there anything that you're super worried about that, oh, wow. Yeah, there's not that much on in vectors. The vector stuff is just that little tiny block. I see we're almost ready to go to our belong. Is today belong? Do we belong today? Okay, we're going to belong today. Okay, let me give you a few instructions before you take off. If you do find, since I didn't upload this until this morning, you might not have known, so take a look at this. If you are scared or worried, you can make an appointment with me for tomorrow or later today, or you can just show up. I'm happy for you to pop in, but if it's a nice day, I might be out on my bike. So if you show up, just so you know. Secondly, you can come as early as 7:30, well, 7:40. Come at 7:40 if you want to do the test, because my statistics class is doing their test on Friday as well. So feel free to come early if you want. I'd rather you not stay late. Finally, if you do have some conflict, because I know there are sport ball people in here, so if you're not going to be here because of sport ball or something on Friday, let me know now. We'll work it out and we'll deal with it. So let me know. I'm going to stop the recording in case you want to come talk to me about something like that. Otherwise, we will see you on Friday with the exam.